All right, in this video, we're going to look at some examples with determining end behavior of a polynomial. But just wanted to start this one with a summary of what we talked about in the last video where we investigated the end behavior of polynomials using Desmos. So in essence, with end behavior, it's really about looking at the leading term, which has a leading coefficient and a power or a degree for it as well. So everything else in the equation for the polynomial is irrelevant. It's the leading term we want to focus on. So with the leading term, one of two things is going to happen, just like we saw in the last video. As far as the leading coefficient is concerned, and that's what LC stands for, the leading coefficient. The leading coefficient could be positive or the leading coefficient could be negative. And as far as the power of the leading term, the degree could either be an odd number or an even number. So if our leading coefficient is positive and our degree is an odd number, our behavior as we go to the left, it's going to go down, and as we go to the right, it's going to go up. If our leading coefficient is positive and our degree is even, as we go to the left, it's going to go up, and as we go to the right, it's going to go up. If our leading coefficient is negative, that's going to reflect each of these across the x-axis, which changes the direction they were originally going. So if our leading coefficient is negative and our degree is odd, we're going to go up as we go to the left, and we're going to go down as we go to the right. Notice it's just the opposite of when the leading coefficient is positive for that. And then if our leading coefficient is negative and our degree is even, we're going to go down to the left and down to the right. So let's take a look at some examples of determining end behavior of polynomials. So to determine the end behavior of each of the following, we have f of x is 4x to the fifth minus 3x squared plus 2x minus 5. And we're only going to focus for this video for end behavior on this leading term, this 4x to the fifth. So we have a positive lead coefficient and we have an odd degree. That means that we're going to go down as we go to the left and we're going to go up as we go to the right. In terms of graphing this, you could graph the entire thing, but you don't have to. You're going to get the same end behavior if you only graph 4x to the fifth. So if you graph this entire equation, you're going to get this exact same end behavior as you would if you only graphed 4x to the fifth. Everything else after that has no impact on end behavior whatsoever. So going down as we go to the left, is the limit as x approaches negative infinity, and going down on our graph means f of x is negative infinity. So the limit as x approaches negative infinity of our function is negative infinity. And as we go to the right, as x approaches positive infinity, the limit as we go to the right of f of x is going up, positive infinity. So anytime you see down for the graph, it's negative infinity, where your y values are negative, more and more negative. Anytime you see up, it's positive infinity, where your y's are more and more positive. Part B, g of x is 12x plus x to the fourth. We can rewrite this as x to the fourth plus 12x. So our leading term is x to the fourth. We have a positive lead coefficient and an even degree. That's going to mean we go up as we go to the left and up as we go to the right. So going to the left, as x approaches negative infinity for g of x, going up is infinity, positive infinity. Same thing with going to the right. As x approaches positive infinity, that's going to the right. Our y values are going up and up and up, so our y values are approaching infinity. Part C, h of x is 4 minus x all over 5, which we saw we could rewrite as negative 1/5 x plus 4/5. We have a negative lead coefficient and an odd degree, so that means we're going to go up as we go to the left and down as we go to the right. So going up as we go to the left is limit as x approaches negative infinity of h of x is infinity. Again, up, positive infinity. And going down as we go to the right, the limit as x approaches infinity of h of x is negative infinity. Again, down is negative infinity. All right, part D here, we got p of x is 2x to the seventh minus x to the eighth. So let's rewrite this in standard form, where our highest power of x here is eighths. That's our degree. So we have negative x to the eighth plus 2x to the seventh. We have a negative lead coefficient and an even degree. So we'll see one of each type of example in this video. So we're going down as we go to the left, and we're going down as we go to the right. So going down as we go to the left is as x approaches negative infinity of our function is negative infinity, down negative infinity. And as we go to the right, as limit as x approaches positive infinity of our function is going down is negative infinity. All right, so that about does it for this video. Thanks for watching, and I'll see you next.